Okay, my friends, so let's do one more example to make sure we drive home the point of this t-testing. And as I was kind of poking around looking for fun data to use that isn't controversial, I stumbled upon my Garmin account and the calories that I burn daily. And this is about a month's worth of data. And you can see it's a little, I cut off the bottom there. And the bottom it says resting calories and active calories. And the resting calories are pegged right around 2,000 or so. I'm assuming that might be the same thing as the 2,000 minimum calorie. I don't know how it's calculated. I have no idea where that 2,000 is. But what I'm interested in is the active calories. And that sent me on kind of a wild goose chase to see, like, am I active enough? Like, am I burning enough calories for a guy my age, my body type, my weight, my height, whatever. I don't know what goes into this. And as you can see, I kind of just kept poking around and looking and searching and looking and searching. And what I eventually stumbled upon was there isn't going to be one exact answer. But when I found this site, it kind of classified it in a way that made sense to me. We're going to break adults of average weight down by their activity level. And I'm going to, just because I know my lifestyle, I'm going to call myself very active. I think that's pretty fair with all the bike commuting and hiking and climbing I do. So then I thought to myself, am I average weight? So that sent me down another rabbit hole where I found by age range, I'm lighter than the average for my age range, which is the 202.5 as I record this video. But is that the only thing I should be looking at? So then I decided to look at body fat percentage. I got that measured last year, and I fall in my age is not in this little graph, but I am in the 11 to 21% category, so I think I'm okay there. But if I check BMI, I'm actually overweight, according for my height and weight. But BMI is notorious for underrepresenting body composition. And as I was down this rabbit hole of average weight and healthy weights, we got this wonderful little test about measuring the circumference of your waist around your belly button. And if it's greater than 40 inches, then you're maybe at risk for heart disease. And I went and checked mine. I'm like, okay, I'm 37, 38. I think I'm okay there. And then I realized I was basically in an ADHD death spiral of trying to find some piece of information. And I had forgotten what I was even looking for in the first place, which was, what classification of activity level are you? So I went back to this original list of, sedentary, lately active, active, very active. I'm going to assume that I'm in the very active category, and I'm going to make a hypothesis. Their top range of calories burned is 1,400. I think I burn more, just based on my normal kind of work output, just how I get around. And I'm going to say I do more than 1,400 calories, and I'm going to use that data set you just saw as indicative of a good random sample of what I actually do year round. Okay, my dear friends, so now let's go get back into that spreadsheet that you downloaded for the last example, because I've got another data set in here, which is my calorie outputs. Okay, so here we are, and let's see if we can make some sense of this. This is the graph you were just looking at. I'm going to go ahead and delete total calories. We don't want total because I don't want to look at these resting calories. It looks like it's giving me 2141 every day, which I'm sure it's not calculating because I'm definitely not burning exactly the same number of resting calories every day. So now we're looking at just active calories, which is the ones I can control with my activity levels. Now there is one thing I failed to mention in the previous video about the data. Since you're dealing with an average, there is kind of one thing you should check before running a hypothesis test on an average, and that's that the data is roughly bell-shaped. So I'm going to real quick make a quick little histogram. I'm going to insert it just like we did before. Insert a histogram. Oh yeah, that looks pretty damn bell-shaped, doesn't it? That does. That's a pretty darn bell-shaped looking distribution. I got a low down here at 282, a high up here at 2722, and then you got this little mount. I'm not even going to bother putting labels on it. That looks pretty darn bell-shaped. And the reason you always check the shape of the distribution when dealing with average. If you've got a highly skewed distribution, the average can be pulled towards the direction of the skew. And you want to avoid that because you don't want your sample giving you a skewed normal, if that makes sense. So this is pretty good. I'm going to go ahead and delete this out. Now, in order to run our hypothesis test, we're going to have to set up a hypothesis in the templates. Let's get that out in here. Here we are. We are still doing average. Go ahead and highlight that. What is
What is our mu? This is going to be Sean's average calorie output. And I can spell that right. I think I can. And I think, isn't that supposed to be a capital C? Isn't that actually a kilocalorie? I don't know. I'll let you dietitian types, tell me about that. Okay, now, I had a claim, and my claim was that I am going to exceed the top, on average, I am going to exceed that top level of 1,400 calories a day. Therefore, the null hypothesis is less than or equal to, let's insert that symbol, less than or equal to, there we go. All right, which one to believe? Well, we'll figure that out with the test statistic and the p-value. We're going to be running a t-test because we're talking about averages. Okay, now we got to get into the Excel calculator. So let's get that thing open. All right. We're going to go over to hypothesis test for a single mean. Here we are. All right, and I've set up, we got to get some statistics out of this. We got to get a sample average, sample standard deviation, and a sample size. Those are the three things we need. All right, so sample average of my calories. All right, there we go. So I average 1429, which is a touch above that 1400. How about the standard deviation? Standard deviation is 527, okay. And then the sample size is going to be how many data points are here? It looks like 28. Yep, 28. All right, so I'm going to grab those three values, and I'm going to come over here. I'm going to drop them in. Remember to paste values if you're doing it this way, so it doesn't paste the formulas in. Okay, beautiful, beautiful, beautiful. All right, now we are going to test against the null hypothesis of 1,400, not 3. I'm clearly burning more than 3 calories. Let's test it against 1,400 calories at 5% significance, 95% confidence. Okay, I'm going to scroll down here. I definitely want a right tail test. This was already preset at X. I definitely want a right tail test. Let's scroll over and look at the p-value. Aha, dear friends. Aha. So you can see the p-value, which means that our test statistic landed right here. So we're doing a right tail test greater than, which means it would shade to the right. So you can see I am above average. Average is at 0 deviations from the mean. But I'm not statistically significantly above that 0. And you can see that down here in the results. The test statistic is 0.29. That's where I landed, 0.29. The critical value is 1.7, which means I landed about 0.3 standard deviations away from average, which is still well within that 95% confidence interval of you're not over 1,400. You're less than or equal to 1,400. I would have had to have landed 1.7 standard deviations away in order for me to believe it. And the p-value kind of echoes that fact. So I'm going to carry these over to here. So the test statistic is t equals, lowercase please, thank you. T equals about 0.3 standard deviations away. Not very much, not very much. It's above average because it's positive, but not really significant, or not, excuse me, not really, not significantly above average. And let me look at that p-value is 38.6%. So just about 39%, well above 5%. So since it's a large p-value, we are not going to reject the null. We have not gotten enough statistical significance deviation from the null. This has to be 5% or less in order for us to reject the null. So we're going to fail to reject the null. So it does not appear that Sean burns on average more than 1,400 calories a day. And there you go. That's your entire test. The only thing I like to have you always do at the end of these tests is to do an error analysis, and that's always kind of fun. This one, since we failed to reject, we believe the null hypothesis, we could have made a type 2 error because we kept the null. Maybe we shouldn't have. Maybe I am burning more than 1,400 calories and I just got deviant data. And type 2 error would be, we claimed that Sean is not burning more than 1,400 calories per day when, in fact, he might be. And I almost got all those words right. Calories per day. Claimed that Sean. There we go. In fact, he might be. All right, there we go. So that's that, my friends. That's your hypothesis test for Sean and his calorie burns. Now, again, it was pretty arbitrary how I decided to pick 1400 there. But again, the mechanics of the test. This is once you have a hypothesis, you can test against it. All right, one more quick video that I thought of while I was doing the math on this one, and then let's get you into the homework.